Hello everyone, welcome back to Sri Chaitanya Academy YouTube channel. I Harish Sen welcome you back to a new session. Right, so today we are on the lecture 10th of our transition course. So let's us first discuss so for the new students who are here, I want to just give you a brief introduction of what transition course actually is, what we are basically doing in this series. Okay, so in this lecture 10, right, we will be talking about differentiation. But what is transition course first of all, okay, for the students who are new here, okay. Transition course is a course for the students, right, who are basically moving or making a transition from class 10 to class 11th, okay. And what are we covering in this? We are covering in this some basics, right, which will help you in class 11th. So now let's talk about physics. In physics, what basically we are doing, right. So let's take an example, okay, that when you learn how to ride a cycle, right, bicycle, yes, what do you focus on first thing, right? You focus on, right, balancing of the cycle, no? You focus on that how you can balance the cycle, right, without falling down, yes or no? You learn how to pedal. You don't, when you learn the cycle, right, you don't focus on that I will go fast as I can go, or I will go in a traffic, no? You focus on balancing the cycle, you focus on pedaling, right, nicely. So same thing in physics, right? Physics is made up of mathematics, right? Physics is just concept, right? That the apple fell down, okay? We observe this, right? That when I throw a stone up, it will again come back. This is physics. But how to tell that to someone else, right? That is with the help of mathematics. And maths is very important. It is the language of physics basically, okay? So now to write physics, okay, to show physics, we need maths. So this is what we are covering in this transition course, okay. So this is the lecture 10 of our transition course, okay. I have covered topics like functions, straight lines, trigonometry, quadratic equations, right, and now differentiation is going on. So I recommend you that those of you who are new here, right, that you go back and watch all the lectures in series one by one, okay. And if you are here only for differentiation topic, right, this is the second lecture for differentiation, okay. So let's continue with this. So in the last class in differentiation, like I will give you a brief introduction, what did we talk about? So what is differentiation basically, okay. So first of all, differentiation is basically slope of, okay, basically slope, just 1 minute, slope at a particular point. What is differentiation? Differentiation is basically slope at a particular point, okay, in a graph. So let's suppose if this is a curve which I have, this is basically my curve which I have, okay. Now if I want to find the slope at a particular point, right, so let's say this is the point where I want to find the slope, correct. So I will draw a tangent to this, okay. You all know what a tangent is, right? You in a smaller classes, if you know that this is a circle, right, a tangent is something that touches the circle at one point, no, and it is perpendicular to the radius, yes or no? So similar for this, right, this tangent just touches the curve at the single point and is perpendicular to this here, okay. So this is the tangent, and the slope for this and the slope for this particular line, right, is basically the derivative of this slope at this particular point, okay. So now what is differentiation first of all, right? So this is what differentiation we are talking about, and how do you write differentiation, okay. So we know that if I want to multiply, right, if I want to multiply, right, I will use this, okay. If I want to divide, right, I will say this. But if I want to differentiate, okay, if I want to do differentiation, right, what is differentiation? Differentiation is rate of change of one quantity with respect to another, okay. This is what differentiation means, okay. So first of all I told you differentiation means slope, right? So what is slope? Slope, if you say, it is delta y by delta x, no? Slope is delta y by delta x, if you know here that this is my y quantity and this is my x quantity, right? So same thing, that what is delta y? Change in x, change in x with respect to change in y. Okay, so I can say change in y quantity upon change in x. Okay, so now when the change is very small, okay, when the change is small, so basically what is differentiation? I can say delta y upon delta x. Okay, so rate, not necessary change, not necessary rate of change, I can say only change of one quantity with respect to another. Okay, so what is the first quantity? Let's say the first quantity, one quantity which you are talking about is delta y. Okay, the quantity is y here, and the other quantity which you are talking about is x, right? So change in y upon change in x, and when the change is small, okay, if change is small, if change is very small, and if the change is very small, what I change this delta to? I change this delta to d. Okay, d. What do you mean by dy? Dy means very small change in my y quantity. And what do you mean by dx? Dx means very small change in my x quantity. Okay, so that is how I will basically in this graph, no, to draw a straight line, what do I need? I need 2 points. So, but in this graph, if I want to find, let's say in this curve, right, if I want to find the slope, I will take 2 points which are very close to each other, and I will join the 2 points to find the slope at that particular point, and that is basically the slope of the particular tangent in my question. Okay, so just 1 minute, let's make it correct, that I have taken 2 points, right, point 1 and point 2, right. When I join these 2 points, right, I will get something like this, and this is basically the tangent. So basically for this particular point, I am finding the slope at that particular point. Clear? So now you should know what is the mathematical meaning and what is the graphical meaning of my differentiation. Correct? So okay, we now know what differentiation is, but see, there are many functions, no, there are many millions of functions in mathematics. So we will now do what? We will now take we'll find some derivative of some common functions. Okay, and what you should do, you should remember them. Okay, you should remember them. Okay, in Hindi, ratta mallo. Why? Because see, if you don't remember them, right, you will face problems. Okay, there is nothing wrong in remembering things. Okay, you will say that okay, we are learning physics, we are science students, and we cannot just remember something by heart. No, if I wanted to do something, I should take bio. No, this is not the case. Okay, here if you remember, no, life will become easy, and as you go on with your journey in class 11th and 12th, you will start understanding things that okay, this is how I got this, this is how I got this. But the first thing is remembering, because that is how you will be getting your marks here. Okay, so first of all, important thing is remember what we write here. Okay, so for a constant function, so first of all, let's talk about a constant function. So now what is a constant function? So let's say my constant function is something y is equals to f of x, let's say, is my function, and let's say it is some constant c. Okay, what is c? C is a constant. So in my constant, if this function is a constant, right, so now what is this? That input is x, no, my input is x, this is my input, and my output is c. So now what is differentiation? Rate of change of my output change of my output with respect to my input, right? What is differentiation? Right, I will say differentiation is rate of change, sorry, not rate of change, change of x, change of output upon change of input, right? I will say change in output upon change in input, right? Now you tell me, in this, will my output change? What is my output? My output is c, and this is a constant value, no, this is constant. So I will say that my output will not change if I change in my input value, no, even if I change my input value, my output will not change. So what do you mean by that? So the differentiation of a constant function. Now what is d by dx? Okay, I will say what is d by dx? Differentiation with respect to x, differentiation of my constant function differentiation of constant with respect to x is equal to 0. Okay, and this is my first formula that I will remember by heart. What is this? Differentiation of a constant with respect to, now you can put here anything, right? Differentiation of a constant is always 0. Okay, next, linear function. Okay, so now let's say my linear function is y equals to ax plus, let's say, b. Okay, this is my some function, this is my linear function. Now I want to find the derivative of this. So what is the derivative? I will say dy by dx, differentiation of y with respect to x. Okay, differentiation of y with respect to x, so this will become d into ax plus b upon dx. Okay, so now there is a rule in differentiation. Okay, there is a rule in differentiation in which if I have two values in addition, no, so I can apply this differentiation function to both of them. So individually, so this will become dA of x by dx plus d, right, this will become b by dx. Now what is dB by dx? Differentiation of what is b? B is a constant value. Okay, a and b are constants. Let's write here, a and b are constants, right? So if this is constant, this will become 0. Now when you have something like this, right, so what can I say? Differentiation of a power x. Okay, this will become how much? A into x will become a. Okay, this x removes here. So now I will help you understand this in more good way where you understand this power function. Okay, let's understand this power function. So whenever I have something like this, let's say I have a function y equals to x power n. I have y equals to x power n. Okay, so now I want to find the differentiation of y, which is y equals to x power n. So I will say differentiation of y with respect to x will give me d into x power n upon dx, right? Differentiation of x power n upon dx. Now let's differentiate this. So now how to differentiate this? Okay, that this x raised to power n, okay, this power will come forward. What to do? Bring this power forward and subtract 1 from it. So what will happen? This will become n power x. This n power comes forward and you subtract 1 from this power, so n minus 1. What is the rule? That you bring this power n forward and you subtract 1 from this. So what do I get here? I will get n into x power n minus 1. Okay, so this is the differentiation of a power, okay, for variable which has some power. So now let's do a quick question or a quick example for this. That what is the question? Let's say the question is that if my function y is a into x, right, y equals to a into x, so what is the differentiation for this? So differentiation for this will be dy by dx is equal to a into x, right? And what is the power here? What is the power here? The power is 1, right? The power is 1. Okay, so now what happens when I differentiate this? That this power comes forward and I subtract minus 1 from this, right? So what do I have? This power will come forward 1 into a into x power 1 minus 1. Yes or no? Now what is this? 1 into a will give me a and to x raised to power 0. And what is x raised to power 0? That is 1. So this will become a, right? So differentiation of y equals to a power x is basically a. And if you look in this, right, differentiation of a into x is a, right? We are getting the same thing. Okay, so basically linear function, right, you can always find this from the power function. But if let's say this is x cube, let's say this is x cube, that one more question, that y equals to x cube, then what is the differentiation? Dy by dx, okay, is d differentiation of x cube with respect to x, right? What will happen? This 3 will come forward, this 3 will come forward, x power, now we will subtract 1 from this power, so this will become 3 minus 1. So this will become how much? This will become 3x square. Okay, so this is the differentiation of x cube. Okay, so let's say now if I have find the differentiation of x power 10, right? So what is x power 10? 10 will come forward, x power 10 minus 1, 9. Right? So eventually what will happen, if you keep on remembering the formula and if you keep on practice, it will become very easy, sir. Okay, okay, clear? So please, okay, practice. This is all a game of practice. The more you practice differentiation, the more easy it will become, right? Why I am telling you this? Because eventually what will happen, that this is, we are dealing in terms of y and x. No, later on I will say that, okay, find the velocity. So what is velocity? Differentiation of position. What is acceleration? Differentiation of velocity, right? So things will become very easy for you if you know differentiation. Okay, clear? So now let's move forward. If I have an exponential function, right? So what are exponential functions? We have already talked about exponential functions in a function parts, right? So let's say that what a power x. So if a function is y equals to a power x, this is an exponential function. Okay, so now let's differentiate this. So differentiation dy by dx, okay, dy by dx, differentiation of y with respect to x. Okay, I am writing, what is this? Differentiation of y with respect to x. Okay, differentiation of y with respect to x. So I will write here that this will basically be equal to differentiation of a power x with respect to x. Right? So what will this become? A power x will become a power x ln a. A power x ln a. And what are the condition on a? A should be greater than 0 and a should not also be equal to 1. This is the condition. Why this is the condition? Because when I taught you log function, right? When I talked to you log function, what did I tell you? That this a should be greater than 0. Yes or no? And this a should not be equal to 1. Okay, this was the condition. So that is why this condition should be valid here only also. Okay, clear? So what is differentiation of a power x? A power x is a raised to x is a raised to x ln a. Okay, now let's do one more thing, that if I take this a and I substitute a equals to 1, a equals to e. Now what is e? Right? So we should not be afraid of this e. What is e? E is simple 2.7, no? This is a value. A is a value, simple 2.7. So now if I take this value and I substitute here, so what my function becomes? My function will become y equals to e power x. Correct? And the differentiation of this dy by dx, right, will be equal to differentiation of e power x upon dx. Right? And thus take this formula and this is my final answer. No, so I will substitute e power x ln e. Ln e. And what is ln e? Ln e is equal to 1. Ln e is equal to 1. So this will become e power x. So what do I get from here? That differentiation of y equals to e power x is e power x. No, the function remains the same. So differentiation of e power x is same as the function itself. Okay, so these are small things that you should remember. Okay, how to remember this? Simple, no? That differentiation of e power x is e power x. Differentiation of a power x is a power x ln a. Okay, and the more you practice, the more you learn. Okay, you have to give time. It will not come automatically. Okay, when I was also studying, I also gave time. Everyone who gives time in their initial studies, okay, this is your initial starting point of your journey. If you give time, if you give effort right now, right, it will help you in the longer run. Okay, so this looks easy, very easy, but this is the most toughest part, because what is this? This is the starting point. Okay, so let's move forward. Log functions. Okay, so let's say if I have log function y equals to log, right, a. Log a, just 1 minute. Okay, let's suppose I have something like this, right? Log x base a. Okay, so if I have something like this, log x base a, then the differentiation of this function dy by dx is equal to differentiation of log x base a with respect to x will be equal to 1 by x ln a, 1 by x ln a. Okay, 1 by x ln a. Now, if here also that a is equal to e, a is equal to e, then what will this function become? Y equals to ln x, no? Right? Then my differentiation dy by dx is equal to differentiation of ln x with respect to x will become 1 by x, right? And ln e, and what is ln e again? Ln e is equal to 1, so this will become 1 by x. Okay, so what can we write? We can write here that differentiation of log x base a is with respect to x is basically 1 by x ln a. Okay, 1 by x ln a. But if I substitute this x with a, then I will get differentiation of ln x with respect to x is 1 upon x. Okay, so we get two formulas from here also. Okay, clear? I hope this is very important. Okay, now trigonometric functions, no? So what are the trigonometric functions which we have? So let's write the trigonometric functions, right? So differentiation of sine, just 1 minute, right? Differentiation of sine x with respect to x. Okay, I can also write differentiation of sine theta, but with respect to theta, because here my input variable is theta, not x, no? Right? If I write, let's say I can also write something like this, that sine alpha, right? Then I will say differentiation of sine alpha with respect to alpha, because my input variable is alpha, right? So it will change with alpha. Okay, what I am saying that differentiation is change of my output quantity with respect to the input quantity. Okay, right? We are dealing here with in terms of x and y because we take input as x, output as y, but I can always change the input to some other variable also. So what is the value I get here? Differentiation of sine x is equal to cos x. Okay, differentiation of sine x is equal to cos x. Second term, differentiation of cos x with respect to x is equal to minus sine x. Okay, differentiation of cos x with respect to x is equal to minus sine x. Next, what do I have? Differentiation of tan x with respect to x. Differentiation of tan x with respect to x. So let's write here, right? So differentiation of tan x with respect to x is equal to minus sec square x. Okay, differentiation of tan x with respect to x is sec square x. And differentiation of cot x with respect to x is equal to minus cosec square x. Okay, you should all remember this. See, this is not intuitive, okay, that there is some logic behind it. Okay, there is some logic, right? We can derive all these formulas, but right now the important thing is for you to is remember them. Okay, next, differentiation of, okay, next we will write differentiation of sec x with respect to x is equal to sec x tan x. Okay, and finally differentiation of cosec x with respect to x is equal to minus cosec x cot x. Okay, so these are the 6 formulas you should remember, right? Again, let's look at them once again. Differentiation of sin x is cos x is minus sin x, sec x is sec x tan x is sec x square, cot x is minus cosec square x, and cosec x is minus cosec x cot x. Okay, so please remember them. So now these are the only important formulas that you should remember. Okay, so if you remember these formula by heart, okay, how many formulas are there? Let's look at them. Okay, so differentiation of constant is 0, first formula. Second is for a linear function, okay, y equals to ax plus b, right? Ax plus b is made up of 2 terms, no? A linear term and a constant term. So differentiation of this constant term will be equal to 0, and a power a into x will become a. So this is my linear term, correct? Next, so there are two formulas. This is my power function. X power n will become n x power n minus 1. Then this n will move forward and I will subtract 1 from this power. Next, I will have an exponential function. So differentiation of y equals to a power x is become a power x ln a, and if I substitute this a with e, this will become e power x. This will become e power x. So differentiation of e power x is e power x. For a log function y equals to log x base a, I will have 1 upon x ln a, and if I substitute this a with e, this will become ln x, and differentiation of ln x is 1 by x. And lastly, we have the 6 trigonometric functions for which the formulas are as this. Okay, so these are the only formulas which you should remember for differentiation, and once you remember these formulas, okay, believe me, differentiation becomes very easy for you. Okay, differentiation will become very, very easy. Okay, now let's move on to some rules. Okay, let's move on to some rules. So what are the rules for differentiation? So first rule is multiplication of a function by a constant. Okay, multiplication by a function by a constant. Okay, and this is very easy. Let's understand the basic rules. Okay, what are the rules? So let's say first that if my function is y equals to, let's say, a into x. Okay, y equals to a into x. Let's say this is the function. Okay, if this is the function and if I want to find the derivative of this function, so what I'll do, I will say dy by dx is equal to differentiation of ax, right, upon x, differentiation of ax with respect to x. Okay, now let's look here. What happens that when I have a multiplication of a function by a constant? Okay, so what is this? This a is a constant here. Let's look here that this, what is this a? A is a constant value and this x is a variable, right? So multiplication of x with a constant. So what happens with this constant? This constant comes out of the differentiation. Okay, this constant will come out of the differentiation and I will say differentiation of x with respect to x. Clear? Differentiation of x with respect to x. Now what is differentiation of x with respect to x, right? So let's use the power function x power n. What is x power n? This n will come forward and I will subtract 1 from the power. So this will become 1, x power 0, and x power 0 is 1, so this will give me 1, right? So what will this become? This will become a into 1 and that is equal to a. Correct? And this is what we got here, no? This is what we got in the linear function, right? So the same thing which we did here, right? And this is quite intuitive, okay? You don't have to, okay. Hello Vedas, okay. Let's move forward, okay. So Vedas, if you please pay attention, and if you have any doubts, you can ask here, okay. So we are talking about rules for differentiation here, that in this multiplication, okay, in this multiplication, if I have a constant multiplied with my function or the variable here, this constant will come out of the integration and I will do integration as follows. Next, okay, so let's do one more question. That let's say if I have a function y equals to a, let's say not, let's do something else. If I have something like this, okay, 3 cos x, let's say this is my function and I want to differentiate this, right? So hello Bhuvan, Bharti, okay. So let's suppose if I want to differentiate this, right? So what to do in this differentiation part? Okay, that this is my function cos x, right? And this is a constant value. So this is my constant value, right? And this is my function which I have here, right? So let's differentiate. So dy by dx will be equal to differentiation of 3 cos x with respect to x, right? And this 3 comes out now. So this 3 comes out and differentiation of cos x with respect to x, correct? Now, so this 3 we can write as it is, and what is differentiation of cos x? Differentiation of cos x is equal to minus sin x. And how do I know this? How do I know that differentiation of cos x is equal to sin x? Because I know differentiation of this trigonometric function, the differentiation of cos x is equal to minus sin x. So I am using that knowledge here and I am trying to solve this. Okay, so this is not something which I rocket science here. Okay, it is very basic, but for that you have to remember the formulas. I repeat again. Okay, that remember the formulas, and once you remember the formulas, right, that will become very easy for you. Okay, so I will explain this problem once again. See, what do I have? Y equals to 3 cos x, right? So this is this is a constant term. No, 3 will not change. What is 3? 3 is just a number and it will not change. What is this? This is cos x. No, so as I change the value of x, right, cos x will change. No, the output will change. So this is my function which I have, and this is constant. So from this, what do I understand? That if I have a constant function multiplied, right, by a constant term, what do? I take the constant out of the differentiation. So same thing we are doing, that this is 3 cos x, I take this 3 and I put it out of the differentiation. Okay, and what do I have inside the differentiation? Only cos x, right? And what is the differentiation of cos x? Differentiation of cos x is equal to minus sin x. Okay, so now I know the differentiation of cos x, I will put minus sin x, and this 3, since this 3 is a constant, it will remain as it is. Okay, clear? So this is, I got the answer, minus 3 sin x. Clear? I hope you understand this, Vedas. Okay, clear? Now let's move forward. Differentiation of sum and differentiation of sum and difference of a function. So now what is this? So let's say if I have some function, right, fx. So let's say I have my function y is equal to, made up of two functions, fx plus g plus minus gx. Fx plus minus gx. Clear? Now, if I have something like this, okay, if I have something like this, right, in that sense, what do we do? Okay, what do we do? So differentiation dy by dx will become differentiation of fx plus minus differentiation of gx with respect to x. Why with respect to x? Because here my input variable x is x, correct? So now in this case, what do? Right, I apply this differentiation on both of them individually. So I will say differentiation of fx with respect to x plus differentiation of gx with respect to x. Okay, so this is what we do here. Now have we done this, right? We have already done this. If you look in this, if you look at this function, okay, this exponential, right, sorry, this linear part, what do I have? This is what fx, no, this is my fx function, plus what is this? This is some gx function, no. There are two functions and I have applied the differentiation on them individually. Okay, so this is nothing, no, this is very easy. Okay, so let's understand this by taking an example here. Okay, that let's say if I have something like this, okay, that if I have a question like this, that fx equal to 6x cube minus 9x plus 4. Okay, so how many functions I have? I have 3 functions, no, function 1, function 2 and function 3, right, and they are, this is subtraction here, this is addition here. So if I want to differentiate this fx, if I want to differentiate my function fx with respect to x, so basically what I am doing, I am differentiating everything here. So 6x cube minus 9x plus 4 with respect to x, correct? This is what I am trying to do here. I am trying to differentiate each of them, right? So let's differentiate. So what I do, I take each and every term and I apply this differentiation on all of them individually. Okay, I will individually apply the differentiation function. So this will become d by dx for 6x cube, and what do I have? I have minus 9x. So I will take this minus 9. Okay, so I will say differentiation of, right, 9x with respect to x plus what do I have? Finally 4, no? So differentiation of 4 with respect to x, correct? Yes. So now what is differentiation of 6x cube? Okay, so for this differentiation of 6x cube, you understand here that this is what? A constant multiplied by a function, no? Differentiation of a constant multiplied by a function. So this 6 will come out, correct? And I will say differentiation of x cube with respect to x, differentiation of x cube with respect to x minus 9, right? This 9 is also a constant and this x is a function, so this 9 will jump out because this is a constant, and I will say differentiation of x with respect to x plus, now what is this, differentiation of 4. Now what is 4? 4 is a constant, no? Whatever input of x I give, this 4 value will never change, no? Correct? So what I will say, this will be equal to 0. Differentiation of constant is equal to 0. Now let's simplify this. So this is 6. Now what is x power 3? What is differentiation of x power 3? This 3 will jump forward, right? This 3 will jump forward and I will subtract 1 from this power. So what will this become? X power 3 minus 1, x power 3 minus 1, minus 9, and what is differentiation of x with respect to x? Differentiation of x with respect to x is 1 plus 0, which I have here. So what does this become? 6 3s are 18, 18x square minus 9. Okay, so this is my final answer, right? This is my final answer, 18x square minus 9, right? Okay, so you understand this? Okay, Vedas, very good, you got the correct answer. Okay, so this is my final answer. But what is important here? The important thing is here that you should understand all the steps which I am following here. That how one by one, okay, we are using the basic knowledge. What are the basic knowledge? The basic knowledge is that these are the two rules which we are using, that multiplication of a function by a constant and sum and difference function, right? And all the basic formulas which we know. Okay, so this is very important here. Okay, I will give you this question for homework. Okay, this question is your homework question, right? I will give you the answer. Okay, if you want the answer, I will give you that differentiation of this dy by dt will be equal to, this will become 8t cube, right, minus 20t plus 13. Okay, this is the answer. Please check and let's find the correct answer by yourself. Okay, and okay, please write in the comment section. Okay, and if you have any doubts, you can let me know. Next, okay, next, let's suppose if I have something like this. Okay, if I have something like this, then how to solve this? Okay, this is also a homework question. This is also a homework question because we have to move forward, but you please try to solve them. Okay, these are very important questions because this will lay the foundation here. Okay, so please try to solve this also. Next, I have a product rule. Okay, so what is product rule, right? What is product rule? That when I have two function yx is equal to fx into gx, right? What do I have? I have two functions which are in multiplication with each other. Okay, and when I want to find the differentiation of these two functions, right, what I will say, differentiation of fx with respect to x, this is basically, sorry, differentiation of yx, not fx, right? So this will become differentiation of fx into gx upon differentiation of x, right? So how to remember this formula? Okay, how to remember this? Okay, so this is that, like, there are two brothers. Okay, brother number 1, brother number 2. Okay, so it is like, okay, you first go, I will go later, and in the second turn I will go and you will come later. Okay, you understand this? What we are trying to do, that there are two brothers, okay, and they want to go somewhere. Okay, they want to go somewhere. So first of what will happen, this first brother will go there and the two brother will remain there only, and in the second turn the second brother will go but the first brother will stay there only. Okay, so let's understand this again. How to write this? That when I want to differentiate two function, okay, the first brother will go and we will do differentiation of the first function. So I will say differentiation of the first function, right? Differentiation of the first function. But what about the second function gx? It will stay there only, it will not move. Nothing will happen to this. And in the second turn, the first function will stay there only. Nothing will happen to that. But now we will differentiate the second function. Okay. So this is the method. What will happen? We will differentiate the first function, keep the second function as it is. Then we will keep the first function as it is and differentiate the second function. Okay, this is what is written here. And this is not that difficult. Let's try to solve that using a question. That now, what do I have here? So we have my first function, right? And I have my second function here. What do I have? I have my first function and I have my second function, and I want to differentiate these two functions, right? So what I'll say, differentiation of ft, what is ft? Ft is a total function with respect to x, is basically, I will say, I will differentiate the first function. I will differentiate the first function, just 1 minute. I should not write x, I should write t, because my input variable is t, dt. So I am differentiating my first function, and what is the first function? 4t square minus t. And I will keep my second function as it is, t cube minus 8t square plus 12 plus. Now what I will do? Now I will differentiate my second function and I will keep the first function as it is. So let's keep my first function as it is. What is the first function? 4t square minus t. Sorry, just 1 minute, I made a mistake here. What is my thing? That I want to keep my first function as it is, no? So I will keep my first function as it is, and that is 4t square minus t. And I will differentiate my second function. I will differentiate my second function, and what is my second function? T cube, right, minus 8t square plus 12. Okay, now let's differentiate this first function. So what is the differentiation of this function? Okay, what will happen? This power 2 will come forward, so I will get 4, I have already, and this will become 2, so 4, 2, and I will subtract power from this, so t into 2 minus 1. Minus, what is differentiation of t? Differentiation of t is 1, correct? Into what do I have here? I have t cube, so this power 3 will come forward, and I will subtract 1 from this power, so 3 minus 1, 2. Minus, what will happen? This 2 will come forward, so 8 into 2, and I will subtract 1 from this power, so this will become t. Plus, what is 12? 12 is some constant, so differentiation of constant is 0. Plus, what is this? 4t square, so this 2 will come forward, so what do I have? 4 2s are 8, and this will become t. Minus, differentiation of t is 1, right? Differentiation of t with respect to t is 1. Sorry, I don't have to differentiate this, no? I made a mistake. I don't have to differentiate this. Okay, sorry. I am really sorry. Okay, look here. What mistake did I make? That this I have to keep as it is. I don't have to differentiate this, no? I have to just differentiate this function, and I have to keep this as it is. So I will keep this as it is. T cube minus 8t square plus 12 plus, right? I will keep this function as it is. So this will become 4t square minus t. 4t square minus t. And what I will do, I will differentiate this function. So what is this? T cube. So differentiation of t cube will, this 3 will come forward, 3t square minus 8t square, this 2 will come forward, so 8 2s are 16, and t, plus differentiation of 12 is 0, correct? So now what do I get here? I will have, this will be equal to 8 into t minus 1 into t cube minus 8t square plus 12 plus, this will become 4t square minus t into 3t square minus 16t. Okay, so this is my final answer. Okay, now we can do all the maths, but this is how you find the derivative of this function. Okay, so what did we have here? We had two functions which were in multiplication. Okay, clear? I hope this is clear to you. Okay, now this is a homework question which I would like to give to you. Okay, please try to solve this question. Okay, here we have three functions, 1, 2 and 3. Here we have three functions, 1, 2 and 3. Okay, I will give you a hint. Okay, what is the hint in this question? The hint in this question is that you try to convert these three functions to two functions. Okay, you try to convert these three functions to two functions, 1, 2 and 3. I have three functions, no? You try to convert any two, these three to two functions, and then you can easily apply the product rule. Okay, so this is the homework question, right? Now we have shortage of time, so in the next class we will start with the division rule and then with the applications of differentiation. Okay, so now let's end the class here. But okay, now if you have any doubts, okay, if you have any doubts, you do one thing, you scan this QR code, okay, and a Google form will pop up. There you can share your doubts, okay, whatever doubts you have. It can be academic, non-academic, okay, and we will help you. And also join our Telegram group. There you will get planners, okay, study planners, and many notes which we have, okay, also daily Telegram questions which help you, okay. So please join, and we will meet tomorrow at the same time, okay. Thank you, have a nice day, bye.
So you want to